Hello everyone, welcome back to this first demo session. Once again, this first session on ABAP on HANA and S4HANA technical training. Thank you so much for all your love you've given me on YouTube and on my different channels, including my profile. Many thanks to all of you, those who are watching me on YouTube, the demo videos, my videos which I posted on YouTube, and the sessions which you guys would have attended by far regarding these different new technologies, be it SAP UI5 Fiori, be it Launchpad, be it Gateway, Fiori enhancements, or ABAP on HANA. Or maybe you've seen some videos on BOPF CDS integration, which I posted on YouTube. Thank you so much for joining this demo session today. In today's demo session, we will have a quick look at ABAP on a HANA technology, what it means for us to be an ABAP developer on HANA database. We will talk about the basics of HANA DB. We will see what are all the technological advancements which are happening in all the three layers of R3 architecture. I will also give you a brief synopsis about the course. And towards the end of this session, we will have a detailed doubt clarification round where we'll talk about different questions which you guys have posted me over the email in last couple of months or days about the server access, about the things which we will be going to cover in this course, what is the prerequisite, what is the learning gap, the right technology, what are all the good things or bad things we got to do. So all these we will be discussing in the session towards the end of the class. I will also open up your lines so that you can ask live questions into the session. We will discuss about the schedule of the course as well. So let's get started, guys, and talk about our three-tier architecture. Just before that, I would like to quickly give you a pointers in terms of what is that in a nutshell this course will include. You can already see here on my screen. We will discuss more about new ABAP syntax with NetWeaver 7.4 and 7.5. We will, our main development tool will be ABAP development tool in Eclipse and SAP Web IDE for developing the Fiori application scenarios for S4 HANA. We will also talk about CDS views and annotation concept, including security. We will discuss about BOPF CDS integration, which is the hottest topic in the market currently for an ABAP developer, whereas you can create quickly the transactional Fiori application using CDS BOPF. We'll talk about data modeling concept in HANA, and we'll discuss about analytical Fiori application creation using CDS views. We'll also talk about SQL scripting in detail with ABAP Managed Data Procedure, AMDPs. This is just a nutshell. There are a lot more things like code inspector checks. How do you migrate your system to an HANA DB? What is that an ABAPer would do at that point of time? How do you migrate a brownfield implementation to SAP S4 HANA? What is your role as an ABAP developer? And there is zero knowledge required on HANA to attend this course. This is one important point and question which many of you have asked me in the past, Anubhav. Do I need to know HANA to be able to part of your ABAP on HANA course? No, guys, you don't need to, because I will cover SAP HANA database also as part of this course. There is no copy paste of code. Generally, you might see a lot of demo videos on YouTube or channels, or you might have seen some trainers. They just run through the PDF documents right from the first page to the last page. This is how they do, and they do a lot of copy paste of code. They just copy from one place and paste it another place, show you the output, and run away. That's not the style of coding which we will use in our course. We will write every single line of code, whether be coding an open item analysis scenario, whether be coding an S4 HANA IDOC scenario, which we will be implementing. We will be also implementing an IDOC dashboard scenario. As you can see here, these are all some real-time scenarios we will be discussing during this course. So we will not be doing any copy paste of code here. We will also discuss about developing smart filter based Fiori applications using SAP Web IDE. This was one of the most asked question by many of you in my UI5 and Fiori training. You've been asking me, Anubhav, can we also create, you might have heard about annotation based Fiori application or smart filter Fiori application. How does it work? How to create them? Can we directly consume it via CDS views? Can we consume CDS data via these apps? How can we improve the user experience with Fiori? So that will be a new step towards SAP Fiori, and the entire development will be taken care in SAP Web IDE, creating the smart filter app. We'll also talk about the BOPF integration to create an end-to-end transactional app with S4 HANA. That is what the overall, in a nutshell, this course will cover. There are a lot more topics as part of it. As and when we will progress, we will discuss. You can already find the course content on my website, onlinefurytrainings.com. So let's get started with the introduction of ABAP on HANA. So the very first thing comes as an ABAP developer in our mind is three-tier architecture. This is what we start with whenever we start learning SAP ABAP, or first step towards SAP, be it a functional consultant or a BW consultant. This is the first step you guys start with, right? Three-tier architecture. The first layer we have is presentation layer, and this is something represented by SAP GUI. Then you have your application layer, which you call it also SAP Basis. This is where all your ABAP program gets executed. And here is where your NetWeaver, which is the technical platform for SAP ABAP, comes into the picture. And final layer is database layer. These are all the three layers which we start when we start learning SAP ABAP. Or any functional module or a technical module in SAP. This is the very first step which we have to learn as part of the SAP language or a SAP technology. The three-tier architectures, very famous. I hope many of you have already seen this or maybe aware of this. So what's going on in these three layers? So over last couple of years, all these three layers are actually evolving, guys, and they are tremendously evolving in terms of achieving something better, something good. The very first thing which is happening, a big change in terms of the front end layer, it's moving towards user experience, a better user experience, because now your consumption is not just on laptops and desktops. Your consumption of these business application is being moved to the mobile, tablet, or desktops. So it has to support now variety of devices. More and more software is now being consumed in the cloud, which means directly by the internet. People don't want to spend a lot of money in setting up their hardware, setting up their infrastructure, setting up their IT teams to manage these humongous softwares. Rather, they would like to just go on a subscription basis, and that's where the cloud industry is growing so fast. And some of the pioneers of the cloud, like Microsoft, we have Amazon, we have Google, and SAP also approaching quite fast in this direction. So there is definitely a better user experience required. So now your presentation layer, still SAP GUI remains in the system, but we have also the SAP Fiori, which is becoming your presentation layer. This is your front end. This is your user experience. This is where user first time consume your business application. Together with SAP Fiori, we have Web GUI, which is nothing but a HTML version of SAP GUI, where you can run your transaction codes still into the browser. And we already have the technologies like SAP WebDyn Pro and SAP BSP. So this is the front end layer. Now these, in recent years, in terms of UI technology advancement, you might have seen that early 2009-10 there was a boom of BSP and WebDyn Pro, and then SAP also had this Web GUI, and now starting 2014-15 we see SAP is moving towards a better user experience to enable the mobile users, tablet users, and desktop users. That's the new front end for SAP applications. In terms of middleware, you see we have something called technical platform for all SAP application called NetWeaver. And the NetWeaver layer is also enhancing. So now we have NetWeaver 7.553, I guess, into the market. So it's also evolving 7.1, 2, 3, 1, 4, and 5. So this is how we have SAP NetWeaver layer also evolving. The lot of new features which are coming up as part of NetWeaver layer. And then becomes your database. There was also a great innovation which has happened into the world of this database layer. So typically with SAP system, we used to use database like IBM DB6 or Oracle DB or MaxDB, so-called MaxDB, and now, or MySQL DB, and now we have SAP itself is actually a company which has built an intelligent in-memory database called SAP HANA. So that is your new database. That is the database which most of the companies are now slowly moving. So that what become ABAP on HANA. You can see when your SAP system, your application layer natively runs on HANA database, it becomes ABAP on HANA. And this is our main goal. Not just this, but we will also actually going to learn how to build a smart filter Fury application. We will look at advancement in technology in the NetWeaver layer. What is the new ABAP syntax? How it is different from the old ABAP syntax? What happens to the old code? How do you do performance analysis? There are lots of tools in the middleware layer. There are a lot of features like integrated data access with ALV. You have full text search, fuzzy search, and there are a lot more features like CDS views, EMDPs, ADBCs, proxy objects. We will be discussing in the middleware layer, and we will also talk about the innovation into the database layer from the scratch, which is nothing but HANA. Once again, I would like to repeat that to join this course, there is no prerequisite except ABAP. You should just know basics of ABAP. Core ABAP is enough. Even object-oriented ABAP is not required to be able to understand this particular course. And also there is zero HANA knowledge required. If you just know the word HANA, that is also okay. Absolutely no prerequisite for this course. If you are an ABAPer in the company, this course is for you. This course will give you an end-to-end full stack idea, and my duty or my complete aspirations will be there towards making you a full stack developer right from the front end, middleware, and the back end layer. So we will be doing a lot of stuff in the HANA DB. We will be doing a lot of stuff in the application layer. And also finally, we will be doing things with respect to user interface, creating the new user interface with these new technologies. So that is the evolution which has happened over the last couple of years into all three layers. And I would say you're already late, but the good news is it's never too late. So companies are still picking up. There are a lot of S4HANA implementations going on around the world, and there are a lot of openings coming on ABAP on HANA into the market at this point of time. This is the hottest technology, I would say, currently into the market. So with that, let's start with introduction of what is HANA. In today's session, we will have about an hour session on introduction of HANA, what has been changed significantly, why people are moving more and more towards their database layer on SAP HANA DB, what makes it so a unique selling proposition for implementing an SAP HANA DB or running your entire ABAP layer on top of SAP HANA, and what exactly gives an edge to SAP by bringing in this database called SAP HANA. So let's start and discuss about what exactly SAP HANA database. As I mentioned, there is zero prerequisite for you. If you are an ABAPer, you have no clue about SAP HANA, this course is for you. You will not need any information prior to this course. If you know, very good. If you don't know also, it's absolutely fine to learn this course. This course is also relevant for people who have been working in BW area in SAP. And you are seeing now there is a shift. People are no more using the BAX reporting. Um, the separate BW system is now kind of becoming obsolete, and it's all moving in a single box called SAP S4HANA with embedded analytics, with complete transactional and OLAP processing and OLTP processing happening in a single system. And that's where the BW relevance is getting more and more obsolete. And now we have a single system where your company is asking you now to build CDS views, right, for analytics purpose. So this is where this course would also help you if you're a BW consultant and you're finding it difficult to survive today into the company by just doing modeling or doing some other stuff you might have done, but that's not sufficient enough to now proceed with your career. So this course is also relevant for you. Yes, I understand for some of you who are experts already in HANA, there will be certain things which will be a repeat, but I would also request you that it's a batch, so all of us are at the same level. So my intention will be to keep things as simple as possible, so even a person with zero experience can also understand, and a person with intermediate experience can also understand, a person with expert experience can also understand. So there will be some sentences which I will tell for my beginners, for some intermediate level students, and some will be for experts. So a mix of that, and that will be my entire motivation for the entire course, to keep it as simple as possible for all of you. Let's get started and discuss about introduction of SAP HANA. What is SAP HANA? SAP HANA, you might have heard on different platforms at least once. These days, you might have heard about SAP HANA. So what is SAP HANA? SAP HANA stands for High Performance Analytical Appliance. What is so important in this? Why it's getting so much of popularity? What is the uniqueness which this database or this appliance is offering as compared to other technologies? Another interesting thing to understand, SAP HANA is a database. Then why it is not called as a database? Why it is called an appliance? We need to understand that, and that is the question which you might have asked yourself many times while you're talking to your colleagues in the coffee corner. You might have thought about it. If it's a database, why it's called appliance, right? We will be discussing about that in a minute. So SAP HANA, try to understand it's a database, nothing more than a database. But what's so special about this database? This is not an ordinary database. This is an in-memory database. Now, to understand this in-memory database technology, we need to go to the basics of the days when we started learning computer. So in a computer, what exactly are the components? So you have something called hard disk drive. Then you have your random access memory, which is your primary memory. And then you have your central processing units called CPU. And then you have your other hardwares and adapters which connects to internet. Let's say LAN, you have WAN, you have different adapters which connects to the CPU. So CPU is your main central processing unit for entire computer, which actually has this power for computing things for you. In engineering days, we must have also read about CPUs. If you remember engineering days, we have heard about an IC called 8084 IC, which is actually a CPU. Okay, it's the simplest example of a CPU. It has 16-bit of address bus and 8-bit of database, right? This is what we learned in engineering days. And then we have generations with Pentium 1, Pentium 2, which is by Intel, Pentium 4, Celeron. Then we have different companies in the market like AMD, we have Intel. These are all companies who are building the CPUs. So the simplest one, which you might have seen or worked with right into on the chip level, is 8084, 8086 ICs in the engineering days. So this is what a CPU which has this computation power, and it can do the computation for you what you need. Then on top of it, we attach something called RAM. The RAM is directly connected to a central processing unit, and it has exchange of the data with the RAM much faster with the RAM. So ultimately, the operations are done within when the data is loaded in the CPU registers. So CPU internally have a small memory, which is in form of CPU registers, and that's where the CPU is actually loading all the data and processing them. Now, CPU then connects to the RAM, and that's where the CPU has a direct access to the address. Because it has an address bus pointing to the RAM, where it can store, read, write the data into the RAM. Then we have the hard disk, because RAMs are costly. Okay, they are very costly, and that is the reason we have a secondary memory, which is nothing but hard disk. And now in the hard disk, we keep all the data. So when you start your computer, what exactly happens? When you start your computer, the entire operating system, be it Microsoft Windows or Mac OS or whatsoever it is, it's getting loaded into the RAM. And that's why the RAM is directly proportional to the speed of the system. More higher the RAM in your system, faster the response time of the system, right? You might have seen these days we have also the mobile phones having larger and larger RAM size. I was just watching an advertisement on Amazon the other day, and there was a OnePlus mobile phone they're selling on a discounted price. It has 128 gigabytes of RAM, right? So RAM the RAM size is faster the computer is considered, right? So but the RAM is very costly as compared to the secondary memory. That's the reason conventionally in the past software industry was keeping all the data on the hard disk, and whenever whatever needed, only that data was fetched into the RAM, which has direct access by CPU. So this was a bottleneck. How exactly the hard disk worked behind the scenes? Hard disk is actually more like electromagnetic tapes. Okay, there are something called cylinders in hard disk, and the data is written onto the hard disk cylinder, and it's an electromagnetic device. To read and write the data on this electromagnetic device, there is a throughput time. Okay, if you have ever seen a hard disk in your life, usually when you read the specification, you get something called an RPM. Okay, every hard disk manufacturer gives a specification for hard disk, and they will put RPM. RPM means round per minute or round per second. Okay, how much time this electromagnetic device, how fast it can move. Yeah, based on this round per minute, that determines the speed by which it can read and write the data. If you ever get a chance to see a hard disk, guys, always watch its label, what is printed there. Check out what is the size. You will see the size written there in gigabytes or terabytes, and you will also see something called RPM, which is round per minute. How fast it can read and write the data. Yeah, but that is, again, there is a limitation to it. Yeah, so it's limited by the number of rotation the cylinder can take, and this electromagnetic tape can take. Yeah, that is what exactly it depends. So that is why where we have a bottleneck in terms of performance of reading and writing the data with hard disk, and that's when the data gets loaded in RAM, and then from there the CPU consumes it. So this is the potential bottleneck for any database system as well, be it an Oracle database or be it a MaxDB, where the data is stored on the hard disk physically, and then when it's needed, when it needs to be processed, it's loaded into the RAM, and then that's where we have RPM limitation comes into picture, and it takes more and more time to load the data. So that's where the bottleneck of performance in terms of hardware was there. But in the recent past couple of years, you have seen now there is a drastic reduction in the memory price. I remember the days when I was doing my engineering way back in 2000. I bought my first MP3 player. It was 256 megabytes of memory. I used to load like 25 or to 30 songs into that MP3 player, and that cost me around $3,000. It was very, very costly. And now at a rate of about $1,200, I can get a 4 gigabytes of RAM, right, for my laptop. So that is a drastic change in terms of reduction in the memory price. So let's talk about what has been changed over the last couple of years in terms of hardware. So now in terms of hardware, you see the first major important thing which has happened is drastic reduction in the memory price. There is also a drastic, or I would say significant, increase in the capacity of fabrication. They can now have a smaller chip which can contain more and more data, right? You see you are getting pen drives of 64 gigabytes or 1 terabytes these days, a very small chip which can contain huge volume of data. That is possible because of new fabrication techniques which hardware industry have built over a period of time. There is also significant increase in terms of embedding the processing power in the CPU. So processing power of CPU has also been increased by means of having multiple cores embedded. So now you see we are getting these days multi-core CPUs. Each core of this CPU is itself a CPU, right? So you're getting a multi-core CPU. For example, there's a CPU, and each core of the CPU itself has a computation power. So you can really command, you can control. If I have to earlier run 4 operations, I have only one core. I have one CPU which has to do it, which has to occupy the process. But now I can start 4 parallel processes together and can give it to each of my core of CPU. That's multi-core CPUs. You might have seen that these days when you buy a smartphone, you also get multi-core CPUs. You like octa-core. Octa-core means it has 8 cores. It has a massive parallel processing capability. It can really process your data. It can really process the instructions which are supplied to the CPU in parallel mode. So that's the new hardware possibility which is coming into the market with these hardware vendors like Intel, AMD's, all these companies. They are building multi-core CPUs, and fabrication has made it possible that now we can have massive parallel processing with these multi-core CPUs. So that's another processing That's another change into the hardware we are seeing. Then together with that, there is also some software advancements. Since the hardware advancement gave us more opportunity to do more things, the memory prices are cheaper now. It's possible for me to design a system where I can keep all my data into the RAM, guys, isn't it? Because I am getting cheaper memory, why do I need to keep the data on the hard disk, which is time consuming? So that's what makes it possible. It's possible with the software advancements also, we can keep the data in the RAM. And that's what the concept called in memory. What is in memory? It's all about keeping the data in the RAM rather than storing the data on the hard disk and having a throughput time to load the data on the RAM and then processing it. We keep all of that into the RAM. Now the question comes, Anu, what if power goes up? Yeah. You still have the secondary memory attached, which is used only for the backup and recovery purpose. You are keeping all the data real time on the RAM, and you still have a backup of that data on the RAM on the hard disk. You just keep taking a backup, keep saving it at different save points as in the hard disk, but you still keep majority of your data on the RAM. Okay, this is what we exactly doing, and that's possible with new software advancement, keeping the data on the RAM, and that becomes in memory. The moment it becomes in memory, there are next generation databases like SAP HANA called in-memory database, the database which keeps all the data on the RAM rather than keeping on the hard disk. That's what an in-memory database is exactly is. And SAP HANA is actually an in-memory database. Together with that, you also see there is a significant change in terms of operating system power. We have now 64-bit operating system, which means now it's possible I can pass on multiple instructions to CPUs much faster speed as compared to 16-bit operating system or 32-bit operating system. Now we have 64-bit operating system which can give commands to the CPU much faster rate, much speed as compared to the older versions. And there are a lot more other software advancements which has happened. We will be discussing about this in a minute. The first advancement is the way we store the data. So we store the data now in column store versus row store. Okay, the typical database stores the data, and since the time when we did engineering or since the time when we joined software industry, you might have heard or listened about the database systems and how do they store the data. They typically store in form of tuples or called records, left to right and top to bottom. This is how they store the data, right? There are lots of disadvantages of that storage mechanism, which is called row store. We will be discussing in a minute what is this column store type of storage and what kind of capability it gives us. Then together with that, if you use column store, we can achieve compression of data. We can store the data. We can avoid duplicating the data. More you avoid duplicating the data, guys, more memory space you save. In a typical database, this can have a great impact. This can have really an amazing impact on your system performance as well as your storage capacity. If you can achieve compression of data without storing the data, duplicate data once again, keeping it redundant, we are storing it again and again. That's what happens in row store. To avoid that, we have a column store, and that's where we can also achieve a great compression with which the speed of the overall system can also be increased. So these are all some advancements. Then we have also something called insert only approach, and then we have building aggregates, on fly. These are all couple of advancements which has happened in the software industry. And now because of these hardware advancements and software advancements together, it has become an SAP HANA. So SAP HANA is not just a software, not just a database, it is actually an appliance. Why it is called an appliance? Because it's a combination of hardware and software. To buy SAP HANA, to implement SAP HANA, you can't simply use any computer. You have to buy the hardware from SAP certified vendors, which is HP and IBM, And from there only you got to buy the hardware for implementing SAP HANA, and then according to the specification you can implement. So it's not just a database. That's why it's not called just a database, it's called appliance, because it's a combination of hardware and software both. It is not just a database. That's why next time somebody asks you why HANA is called appliance, you have the answer of this interview question. Why it's called appliance is because it's a combination of hardware and software. It's not just a software. That's why it's not a database. It's a database. It's an in-memory database, which means it's keeping all the data into the RAM and using the secondary memory only for backup and recovery purpose. But it's an appliance, which means it's a combination of hardware and software. I hope this is clear to everybody. The what is SAP HANA? I'm sure I'm going to take up your question. So today it's a demo session. In this session, I'm not going to take up the question in the middle, but regular classes which will start from tomorrow, we will also pick up the questions in the middle. We will also give you a break of 5 minutes after 1 hour. That will be happening in our regular sessions. Now, as far as today's demo is concerned, I will give all of you an opportunity to ask questions on these topics which I'm covering today towards the end of the class. Okay, we will we'll keep 1 hour of time only for questions. So demo will be only for first 1 hour, and the remaining 1 hour we will be having question and answers. So let's move on and try and understand what is this column store versus row store. So let's take a typical example of storing the sales order data. We all know as part of basics that we store the sales order data in an ERP system in a row fashion, or typically in any database system, the data is stored in a row fashion. Now, suppose it's a sales order data. So sales order data, we have something called sales organization, let's say 1000. Then we have a distribution channel, we have sales area, then we have ship to party, let's say SH1. We have sold to party SO1. Then we have material. Likewise, I am storing all the data for multiple orders. Now, in case of a row store, the data is ordered in sequential manner. Like this, the data will be stored. So let's say your sales order number 1001 is having sales organization 1000, 10, 00, ship to party, sold to party. Then you have sales order number 1002. This is having again maybe sales organization as 2000, distribution channel 10, division 00. Then we have ship to party, sold to party. Then we have sales order number 1003. Like this, we are storing all the data. 1004. And let me just quickly make a copy of this data here and just say maybe this is 2000, this is 20. Then we have sold to party as 2. Then we have here this sold to party as 3, ship to party as 2, and then we have 1005. So likewise, this we are storing all the data in a row fashion. Imagine this is your data store. This is where how you're storing data for your typical VBAC table, which is the sales order header table. Let's imagine this is your data. So what happens in a row store system? The data is stored in sequential manner. It's stored from left to right in the memory. This is a replica of the memory, how memory is storing the data, guys. That is what is happening. So it's storing left to right like this. This is how the data in a row store, a typical row store, is stored, guys. Okay. Now, what happens is in a row store, if you assume and if you see, observe, suppose my requirement is to find out here what is the total sales amount of all sales orders. Yeah. So total sales amount of all my sales order. Please get me the total sales amount for all my sales orders. So let me note down here 500 euros. And then we have this one is 300 euros. And then we have here, let's say 600 euros. Then we have here this one as 100 euros. And then here we have 350 euros. And the last record we have, let's say 800 euros. This is my data in the sales order header table. And now my requirement is to find out the total amount of sale with all the sales orders. What do you think how the system is going to read this data and how the system is going to interpret this data to calculate the total of sales? What is that? How the system or how the computer is going to start reading this data, how the database management system is going to read this data. To calculate the total of sales order amount, what system exactly does, it starts traversing from left to right. Now it picks up the first sales order amount. You can see here 500 euros. It is now still going through these tuples, these cells of the table record. It picks up this 300, and then it moves on and it picks this 600, and then it starts with the next set of memory locations. It is traversing. It has got this amount. Traversing. It's got this amount. Traversing, and it's got this amount. So now to calculate the total of the sales amount, system has to go through the entire records, entire table, right? Unnecessarily, it is also passing through by these cells, which are actually not required to calculate the total. But that consumes the time. That consumes the time to calculate the total, guys. The second disadvantage of this is how the row store works, guys. So the first disadvantage here, if you talk about the row store, in case of this example, if the data is stored in the row store format, the below disadvantages occurs. The first disadvantage here in this case is we have to traverse all the records and all the cells. Even we are interested in single cell, right? This is the first disadvantage of the row store approach. The second disadvantage, guys, let's imagine somebody would have changed the data. Somebody would have changed this particular ship to party or sold to party in this record. What do you think system has to do? System has to re-replicate this whole record for logging purpose. If you know, there is something called IP compliance in a ERP system. We have to track change management. We have to have change management, which tracks every single change happening to your business data, right? Now, to be able to now track the changes, the moment you change even a single cell, the complete record is written in the change log. Okay, we have change log. In the change log, the complete record is replicated and written. Even you changing a single cell value, a single column value for a single record, the entire record is rewritten in the change log, which is actually disaster for your memory consumption. Huge memory consumption because of this. So even there is a change in a single cell, there will be the entire record will be rewritten inside the system change log, leading to high memory consumption. And now, guys, to optimize the read performance, what else do we do in such a system? We create indexes, right? So we have to also create indexes in such a system where we have to optimize the read of the data. And this is where the secondary indexes in an SAP system comes into picture. You have to have lots of change tables, change log tables. Together with that, you have to also have lots of indexes to be able to access the data faster. You have primary indexes and you have secondary indexes, which are also physically storing the data of the primary key fields plus the pointer to the exact record to speed up your data read. So that's a third disadvantage. We would need lots of indexes to be able to speed up the read of data faster from this storage. Yeah, that's a third disadvantage of a row store system. Yeah, this is why a typical ERP system has humongous database size. It's a very big database size. And now, guys, look at here what SAP have done with SAP HANA. They have done a software innovation, and now they have they are storing the data in form of column store. What does it mean to store a data in column store? How does it look like? Watch out here. You are going to break down every column which you were having in the table into a tiny table. Okay, just imagine I am breaking down every column which I was having into a tiny table. You also observe in the row store the disadvantage, guys. You see here the shift to party sh1, it's repeating. Yeah, almost every record having same shift to party. Can you see that? Almost every record has same shift to party. So I'm highlighting with the color each shift to party. You can see we have another set of shift to party which is repeating. So we have two sets of shift to party which is repeating in every record. That is what is happening. When this is happening, guys, which means it leads to heavy memory requirement again, because you are storing redundant data again and again in every record. That is also a disadvantage. The fourth disadvantage of a row store, the data is stored in rows or sometime repeating, hence they are stored redundantly. So the data storage has high value of non-unique values, okay, or high range of non-unique values which are repeating, hence would need more memory space. This is the disadvantage of typical system, and that's the reason, guys, you have it is all leading to a high memory requirement in a ERP system. Now what SAP have done, they have said, okay, hold on, let's bring it on column store. What does the column store does? A column store, what it does is we are going to break down every single column in a tiny table. So now imagine every single column which you have in sales order table here is broken down in a tiny table. Okay, everything is a tiny table. So now if I'm going to store the data for this tiny table, watch out. The first column, which is my sales order number, I'm storing 1001, 002, 1003, 1004, 1005, and 1006. These are all my records of sales order numbers. Now for the sales organization, you see 1000. Then again, you have sales organization as 2000. Then you have again repeating 1000, and then we have 2000, and then we have say this is 1000 again, and we have 3000. So like this, we just have three unique sales organization, which is 1000, 2000, and 3000. I don't need to store this information repetitively. Let me store for time being repetitively as per every record. So first record is 1000, second record is 2000 sales organization, third record is again 1000 sales organization, fourth record is probably, in this case, I'm having 2000 again, yes, and then we have 1000, and then we have 1000 again. So like this, for all six records, I've also stored, let's say, duplicate values for in the tiny table for sales organization. Similarly, I will now store all the values which are there in a tiny table in each column. And now, guys, if you observe the pattern, let's say you shift to party also sh1. So that's the shift to party column table, tiny table, sh1, sh1, sh1 is repeating, sh1 is repeating, sh2, and sh2. Observe the behavior, guys. This is how typical ERP data is. If you go back to an ERP system, let me show you quickly. What do you think? How many columns your Mara table has? Anybody? Any guess? Anyone would like to tell your experience? How many columns your Mara table has? Anyone?
26.
It's 200 plus.
32.
200 plus columns. More than 250 columns.
250.
Yes.
Close to 300.
Let's go and check it out. I go to Mara table, and now you see it has 316 fields. Do you see every field of Mara table has unique values? When I look at the data of Mara table, do you see every column has unique values? Anybody? Do you think every column has unique repeating value? Do you think every column has, in every record has unique values? Is this unique? No, no. It's repeating. It's not unique. It's repeating. Look at here. You see, this complete thing is repeating again. L2, it's repeating again. You see here, M brush column, M, everywhere it's M. It's not unique. This is the pattern which you can observe in any ERP system. Look at here. In any database table you open which has like so many columns, you'd see less number of unique values. 4 से 5 या 6 वैल्यू होगा, वही वैल्यू हर रो में रिपीट हो रहा होगा. You can see here this Hava or this ROH or this M in this case, it's for every record is the same value. It's a non-unique. Yeah, it's non-unique. It's not a unique value. Yeah, what is unique here? L001 is unique, L002 is unique, L004 is unique. That is unique. But you see, more and more non-unique values are repeating. See here, non-unique values are repeating in the system. So when such thing happens, non-unique values are repeating in such a system. You can see here, which is a typical case in any ERP table. Utha ke dekh lena, it's repeating the values. What can we do in column store? We can avoid storing these values again and again in this tiny table. We can say, hey, I understood that you have a fixed set of values which you are repeating in almost every record. I'm not going to store it again and again. What I'm going to do is I'm going to write down these values only once. So SH1 only once. And I'll say, kahan repeat ho raha hai? First position, second position, third position, fourth position. I have found out, okay, you are repeating this at 4 positions. And then SH2 is repeating 1 and 2. That's it. Done. You can see, guys, reduction in the size to store this data. You can reduce the size to store this data. Similarly, sales organization, you have non-unique values again. So here 1000 is stored at position number 1 and 3, 4 and 6, or 4, 5 and 6. And then coming to 2000 is stored at position number 2 and 4. Yeah. So like this, you can avoid storing these values again and again. Yeah. And that is what has given an edge to you to avoid now storing the duplicate values which are non-unique. And that's what typically happening in every ERP system. You see, every record has almost same values repeating. In row store, you were actually storing this data, this redundant data for every row. Here you're not. So automatically your footprint of memory is reduced when you go to column store. The second the advantage is not having indexes anymore, because each tiny table is itself an index. Yeah, if I want to know what is the sales organization at position number 5, you can simply go 5 number pe kya hai, 1000 hai. So every tiny table itself is an index. So now I don't need to read or store duplicate values. Point 1. So this particular thing is solved. You don't need indexes anymore, because each tiny table also index itself is an index. So point number 3 and 4 gives an edge to you in case of a column store database. Now look at also the calculating total. The first example where we have to traverse through all the record. Now can anybody tell me, to calculate the total, how many records I have to traverse through? Now if I break it, this sales order amount also into a tiny table, so I have 500 euros, then I have 300 euros, then I have 600 euros, then I have again, let's say, what is the next value? It's 100 euros, then we have 350 euros, and finally we have 800 euros. This is the data. I have broken down every single column in a tiny table. Now guys, what do you think? System, to calculate the total amount of sales which has been done in my company, how many cells it has to traverse through? Anybody, can you tell me, does it need to traverse through all these cells? Does it needs to traverse through all these cells? No, it just have to go, hey, to my tiny table which is storing the total sales, can you get me this? That's the power of column store, guys. It just has to traverse through directly this data and get you the total, guys. That is the biggest advantage of column store. And that problem is also solved now. So you will see a drastic reduction in the memory footprint, a great compression of the data. There is no more repeating set of data stored. So there's a drastic reduction. No need to store secondary indexes. Additional secondary indexes are not required. And then coming to this point where you want to change the data, does it have to rewrite? No. If you just change the data, let's say at position row number 1, you just change this one, shift to party 1 to 2, you just have to change this index. यहाँ से index उठा के नया record डाल दो. So this is called insert only approach. What it does in HANA, it's a column store and it uses insert only approach. Every time you change some data, what HANA does, it does not go and find that record and remove or change. It simply insert a new record with new latest timestamp. Okay, what is timestamp? Current date and time. When you fire a read, it fetches the data with the latest timestamp. Okay, it doesn't go back to the records which are obsolete with older timestamp. So with the timestamp store, every time you make some changes, every time you do some change, it actually insert always a record. So don't have to worry what is there. You just keep inserting with latest timestamp. When you fire a read select query, it automatically has this inbuilt functionality inside HANA with column store. It goes and picks up the record with latest timestamp, the cell with the latest timestamp, and that's called insert only approach. How HANA optimize the inserts, updates inside the database, picks up the latest timestamp. And that's what also changed or solved the problem number 2, where there were change logs which you need to write, because each record with the timestamp is itself a change log for you, right? Change log bhi write ho gaya, aur uske baad mein when you're reading, it's reading with the latest timestamp, so you're getting the latest results. That's what HANA does. Insert only approach they have used to be able to manage the changes and write the change log within the same tiny table for column store. Hope you guys are clear with all these approaches. What is the software advancement in terms of HANA, how it is simplifying the overall architecture of the system in terms of database. So now a quick nutshell, what is that we're going to use? We're going to use the power of this powerful database, powerful appliance called HANA appliance. We will be looking into the features of HANA. We're looking into the deep into the architecture. Just to show you PPT of my last completed batch for ABAP on HANA, just to show you guys what is that we are, just to give you a glimpse of what is that we're going to learn. So this is my PPT of last batch. We're going to learn about core to data paradigm. We're going to learn about what is the advancement. We're already discussing that. Yeah, we will discuss about server details. We'll talk about different systems. We'll talk about architecture of the system, how it is simplifying the architecture. We'll look at the HANA platform architecture. What are all the different components inside the HANA DB? I'm going to teach you HANA DB also in this course, guys. So don't worry, you don't need to know HANA DB. We will talk about the different releases of SAP HANA, what has been changed, what has been advanced. We'll talk about ABAP development tool using Eclipse ADT, installation setup of ADT. We'll talk about features of ABAP, guidelines. We'll talk about our OIA scenario. We'll talk about modeling in SAP HANA, the views, how to model views in HANA. We'll talk about proxy objects, HTC, containers. We'll talk about SQL scripting in detail. It's an open challenge. No trainer is teaching SQL script today on internet. No trainer, not even close to it. Even you have taken HANA training, I bet you they wouldn't have taught you scripted calculation views, because that requires programming. SQL script programming. We will have a deep dive inside SQL script programming. We'll be discussing that. We'll look at HANA administration a little bit. We'll talk about coding procedures, functions. We'll talk about S4 HANA, what it means for you migrating to S4 HANA. What about your custom code when you're going to S4 HANA? We'll talk about S4 HANA implementation cycle for brownfield implementation. What is the job of an ABAP developer? We'll talk about CDS views. We'll talk about annotations. We'll talk about CDS analytical consumption. We'll talk about S4 HANA embedded analytics. We'll talk about virtual data modeling in CDS. We'll talk about CDS security. We'll talk about associations in CDS, creating the Fiori application, BOPF integration with CDS. We'll talk about different architectures, different way of how people are building these apps. We'll talk about ALV with IDA and lot more features about ABAP on HANA. Complete deep dive pro training on ABAP on HANA along with S4 HANA technicals with killer scenarios of type Fiori applications, end-to-end virtual data modeling and CDS modeling with S4 HANA. This is what will be in a nutshell, just to showcase you kind of an application you will be building in this course. Let me just connect to my system. So kind of applications we will be building. I just show you a glimpse of kind of application you will be able to build towards the end of this course, and we'll be able to give it to your end users. They will be pure Fiori applications. You will be able to build an ABAP on HANA using CDS and annotation and different concepts which we will be covering. So this is our system. It's an S4 HANA 1808 system, and I'll just quickly show you the application which we had built in the last batch and deployed it here. You will be able to build this kind of applications also at the end of this course. That is what will be our goal. We will look at creating a smart filter as well as analytical applications. So you see here we've created an iDoc dashboard application. So that is something you will also be able to build uh, at the end of this course. This is a Fiori application of dashboard, analytical dashboard application. So we'll be able to build that, and that's all will be on CDS view with annotation concepts. You will be able to create. It's an OVP application, overview page application. So it includes something called cards. We will also build approximately 3 to 4 Fiori apps which are using OVP scenario. You see this kind of application you will be able to build towards the end of this course. Yeah, we will also see you will be able to build this kind of smart filter application where you have filtering capabilities. Just to show you, you can see here you can build this kind of applications where you'll see filtering capabilities, searching capabilities. So all these applications you will be able to build towards the end of this course. That's about a nutshell about the demo. In the next session, which is planned tomorrow, just to I will brief you also about the schedule of the course. So the next session, which is planned tomorrow, we will start with introduction of SAP HANA architecture. We will also talk about what it means in terms of ABAP on HANA and how SAP HANA is simplifying the world of BW, where you used to have separate BW system, used to move the data from transactional system using ETL processing to BW and then do reporting on a BW system, which is now no more required because SAP ABAP on HANA has changed the game. It has brought in both the analytical system and transactional system in a single box, and that's the innovation which has changed the world, the way you look at. We will be able to become a full stack developer by the end of this training. End to end, you will be able to build everything on all the 3 layers. Of course, the UI5 and Fiori, if you want to go deep dive, there is a separate course on my website. I hope you already know about my website, which I'm recommending everybody to have a look at to get used to this new technology. Today, for you guys, survival is the question. And everywhere, when I talk to people, I see confusion, confusion, and confusion. Somebody come and say to you, you assume something else, and then you start asking wrong questions. Guys, you should ask right questions, and you should also bring back your confidence, which you had earlier when you started in the area of SAP. Bring back your trust, bring back management trust in you, bring back your respect which you lost over years by not learning things, not keeping yourself up to date. Because of that, you would have lost the the confidence in yourself. You would have lost the respect which you're supposed to have in the company. Now you see juniors are coming, they're building Fiori apps, and you are sitting idle and looking at them. You are also not able to estimate things better. If you are working as a manager, people are coming and telling you something and you got to just accept it because you have no clue about this new technological changes. Many managers comes and take training from me because they say, hey Anubhav, it's a big problem, technology has changed all over the layers, and now people are giving us and giving wrong estimates, and we are unable to answer anything. I am sitting in a meeting room where there is a Fiori development going on, and I don't understand a single word what they talk about, and they don't even care about me, they don't respect me because I don't have an idea. Guys, I will bring your respect back in your company. Each one of you is equal to me, and as I mentioned, there is zero prerequisite to learn this course. There is no HANA required. If you just know ABAP, more than enough for me. And if you are not interested in programming, don't join this course. This course is for programmers. This course is for developers. This course is not functional. Some people are still under assumption that I'm going to teach simple finance. No, we are not going to learn functional here. We are going to do pure technical stuff, all about coding, programming, development, hardcore development, learning all 3 layers, designing, developing apps which can consume the data, your reports, different types of scenarios we're going to take up. All that is hard coded coding, guys, we're going to learn in this course. This course is for developers. If you're a BW developer or a BAP developer, or you want to become a UI developer, this course is for you. Now, again, just to tell, if you are an absolute beginner, my recommendation to start with UI5 Fiori is still you can start with ABAP on HANA, absolutely no problem. You don't need to know UI5 Fiori at all to be able to learn ABAP on HANA. Not required. So any one of these modules you should start with, either this one or this one. Then you should jump to the another one. If you're learning ABAP on HANA first, you can move to UI5 then later on. And then from UI5, you can go to Fiori Advanced Training. Fiori Advanced Training is all about building things into the cloud using SAP Web ID Full Stack, becoming a Fiori security consultant and a Fiori architect. If you want to do advanced Fiori stuff like QUnit, OPA 5 testing, you want to become a full stack Fiori developer, you want to do storyboard, you want to do quick prototyping using Fiori build tool, you want to do Fiori security related stuff, creating roles, authorizations, groups, catalogs, debugging the launchpad, finding out the issues, theme designer, applying the custom Fiori apps, deploying the apps, changing the standard SAP Fiori applications, want to work with extension of standard OData services, the advanced Fiori course is for you. So watch out here the courses, download the course content, check out the course content carefully before deciding which is the right module for you. With that, it's a wrap on today's demo class. Thank you so much for watching as usual. I love all of you. You are sending me a lot of good response on YouTube. I'm mesmerized with the kind of views and likes on the YouTube channel. You all have been phenomenal in sending the feedbacks over the email and asking the questions. If you like this video on ABAP on HANA, please do like, subscribe, and share this video with your friends, colleagues. Thank you so much again. Goodbye.